Ahoy, what's up? How's everybody doing tonight? That's good. I'm glad. All right, so this is a hodgepodge of wires and circuitry. This is supposed to be two SGs over here. I believe it is, with the way everything's hooked up. We got a nice big resistor, 5% tolerance. Um, but over here, and this one's hooked up to this little motor right here. What I did was I took the resistor out of the equation because the magnets are so much smaller. That was just my thought, that it would need to not go through such a large amount of resistance to function the way it's supposed to. And that's a milestone. That little rotor right there goes about 1700 RPMs. At 9 volts. So I'm going to put it at 9 volts. And another cool thing is this coil here, right here alone, can turn this light on through that bridge rectifier. And also I have the multimeter hooked up with like excess, voltage on top of the light. So you got yourself a little load, and then you got more after that. See, there goes the light. And this is a single file coil. So I mean, there's no interaction going on, which would be going on with if you used an SG. You can do it with a lot less wire, but it's a totally different process, the way you get the energy from SG and a single file, like induction. But it's not like heat induction. It's not. But all this energy right here is coming from the magnets passing the coil. No other way. So we'll get a view at the amps first. Yeah, I think the amps are a little high for DC, but more than 1.5 amps. Now if we go to voltage, .1 DC volts, and the light and the load is on the coil too. That might be what's doing it. It's cycling the amps through the light. The light might be amplifying that somehow. Right here, I want to get this little baby going, because I mean it's pretty fast. It might take a few spins though. I don't know why it takes so long. Well, that's good. It's going. Sweet. Now let's turn it up to like a 12-volt battery. Oh, it won't let me do it. Yep. Okay. So 9 volts is like 9.5 volts to run both of them. The amps are at 1.8. I'm gonna get something to drink real quick. I need some A&W. Listen to that baby hum. Listen to it though, man. That is going extraordinarily fast. But it is a little rotor, so 1640. Yeah. Woo. Now this one's not going anywhere near that fast, and it doesn't need to go that fast. 569. But like when you start that thing, it's like there's a PNP in here somewhere with all the MPNs. There's a PNP in here somewhere, and when you turn that one on, the amps just go through the roof all of a sudden. It'll either continue to run or it'll stop everything. And that's why you can't go up to 12, because I go up to like 9.8 and I'm already running through 2.5 amps. At that rate, you know, you're going to blow something out before you get to 12. So this one will always go slow, well this one goes fast. And I gotta split them up. Like I gotta have one power supply for this one altogether and then one power supply for this one. Right now, they're all running on one power supply. I don't know how, but it works. So, but I have batteries now and I can like, but I was like thinking about making a flyback situation where the batteries like charge each other. But I don't know, I might have to get more batteries and then like just for the first time divide the power supplies legitimately, like have one battery per coil. Even though I don't need to do that, I don't think it would give me a really more clear, crystal clear idea about what's going on. Because it's like, I'm reading, this is input for everything that's going on the table. And there's a lot going on. So, I mean, maybe we could simplify it somehow. Yeah, a little guy. Alright, so the little one's literally going like 3 times as fast as the big one. But the big one is generating, I would have to say a total of about 120 volts. But then you got the light running. See, but this is the weird part about the whole thing. There's no wave. There's no wave going through the bridge rectifier, and I'm pretty sure that's exactly where the bottleneck for all this equipment is in the bridge rectifier. The amps and the voltage will go through it, but the frequency, the capacitance, all that stuff is having trouble getting through. So I'm going to do an AC test for everything. Might as well set that up now. All right, so the green one goes there. Black one goes there. Oh, I'm gonna have to fix that. All right. All right. So that goes back over here, and this goes back over there. Let's spin it real quick, make sure it's still moving. All right, so it's not blocked. And then we got to hook up just right on the wire. So we're setting up an AC version of what I was just doing. We should get a load on the rotor with this version. I could even do both, but I think it would blow up my scope over here. Have a DC and an AC reading pumping through it at the same time. I don't know. But that should do it. You got let's spin this and see. Yeah. You see the wave starting to form a little bit. I'm dying to see what's going to happen when I turn it on. I mean, a lot of people might already know what's going to happen, but I really don't know. I don't know. All right, AC, lighten up here. How's that wave look? Square wave. Nice. Now I bet if I turn that light off, it's got a switch, so I'm going to turn it off. What does that look like now? Okay. It's more of a sine wave now. Oh, yeah. Yes. So without the load, you got a sine wave. And then with the load, you can see how it takes the energy away from the wave on both sides. And you can hear how the rotor is slowing down. But it reaches a point of where it stops slowing down, and then it continues to work, continues to run at a steady pace while running the light. And that is effectively having a load on the circuit And we're going to see what the volts are now. Because I know the RPMs are low. $75. Perfect. It's about exactly the same voltage on top of the light. So you got that. Now let's see about the amps coming through. See, there's a lot less amps coming through with the AC version. A lot less, like 1.4 amps less. I do have an Arduino, yeah. It's on the table and I'm learning how to set it up, so it shouldn't be long now. But no, I do all this stuff without all that, and I probably shouldn't, but I do, and it works. 9.5 volts in with a 0.7 amp draw for this motor, right? I'm going to start this one. No, that's not it. Yeah, okay. There it goes. The only fluctuating reading that I got lately. But it goes up to from 0.7 to 1.5 amps on this little one. I find that pretty fascinating. I didn't expect the amps to go up that high. 1.9 amps. So that means actually this little motor is taking more amps than this one, bar none, like by a lot. But it's also going a lot faster. And that's why I said there's a PMP in here somewhere. I love the grind on that, man. That sounds like a saw when it speeds up. See, now what bugs me is when I turn it off of the amp, the light goes off. Oh, we're getting something though. That's good. About the same frequency as the input, about 60. Capacitance is at 130 NF. And resistance, I can't believe it's reading this right now. Oh yeah, but it's not moving, so it says like 170 ohms. But I know it's way more than that. Like if you turn the motor off and you do it stationary, it's over a K ohms. Oh. So I don't know. And we do that. We're gonna do that real quick. See if it's just the meter acting up or if that's real. Now I got some ferrite magnets coming in for an axial flux rotor, and they're going to stack double, and then they're going to be kind of clamped in there a little bit, and that'll be a nice rotor. And then I can start reorienting things and start building things a different way, because I've been doing this for like a year and a half now, and I'm yearning to do something different, but along the same lines. Wouldn't know the first thing about it. All right, so let me explain the rotors here a little bit, and then we'll go into the coils. All right. Oh yeah, I printed off this, Tinkercad has some predefined, printed off this little fan. Didn't know it was going to be so flimsy, but it's kind of cool. All right. So we got one DC power supply that is fed into, I probably should get that in the shot. It's an Eve model power distribution. So you got your positive and your negative. You got 10 ports there that do that. And as far as I know, it spreads the power pretty evenly along those lines. So I don't know for a fact, but I say there's pretty like a lot of room there for it to mess up and not do it right. So I was thinking about having, at least a 12-volt battery for each coil assembly and each transistor. I don't know, that's pretty pricey, but and then start thinking long term. Could even use like these two power supplies, and I have two batteries, and wham bam, we got one coil here, one coil here, one coil here, one coil here. There you go. Your 4 power supplies. You just gotta be real gentle with that drock. That's it. Because the knob is got a very small turn. You can't. There's not a lot of room to turn it. So like the voltage goes up very fast when you turn it. So you gotta be very gentle with that. But yeah, I could do that right now. I could have a separate power supply for each power input that I have. That would be great. I've been thinking about that. Because I'm sure the readings would be different than the total sum reading of what's going on here. So we turn this on. Is that what I want to do? I want to turn it on? I don't know. I just turned it off for some reason though. I can't quite remember why. It doesn't matter. It's alright. It'll come and go. All my ideas kind of come and go. So yeah, we'll turn it on. Now the magnets are loosely placed in the rotor. Oh yeah, we were going to talk about the rotors. So there's 6 magnets in this rotor. 1-inch cube neodymium And they're all facing north. I could get that. That might be a cool thing to demonstrate. And I noticed something in the between zone, like between the magnets, is either, it depends on whether you do bipolar or monopolar. Because with the bipolar setup, in between doesn't give you a reading at all. Okay, there's nothing there when you put it in between. But when they're monopolar, in between becomes the opposite pole of the magnets. Okay, so you do get a bipolar setup. I wonder if the coils feel that. I mean, it registers on this thing, so the coils must feel that south pole. So there you go, you get a bipolar experience no matter what way you do it. But the cool thing about doing it bipolar is that you get that 0 point, that nothing, and that gives a coastal, like when you got to factor in, like if you have enough force to coast and you end up coasting faster than you're forcing, man, you'll have like a slowdown period. But that coast is when it's nothing, then the coil experience is nothing, and you're coasting. And when you're moving without spending or energy one way or another, it's a good thing. Coasting is awesome. I should do a bipolar setup just so we can see that nothing zone, and it's pretty like right there in the middle, man. And there's just no field there whatsoever. Yeah, I think that little tool is fabulous, man. It's great. Cause I thought I had everything north at one point, and it was all south. But it was all together, so I guess it worked, and you couldn't really tell that it wasn't doing what it was supposed to. Um, and the only reason I say that is because I think north is inherently a little bit stronger than south. I mean, that's what I've heard. Hmm. I don't know if that's an actual fact, but I think that's a thing. I do. And I mean, this coil right here, it's got enough juice in it to light this up as bright as an SG. Okay, as bright as an SG. I mean, a voltage will get it so far, but to get it that bright, you got to have some sort of amperage. And the AC version is far less bright than the DC version, which has 1.4 amps. Yes. Um, and the AC version, which has like 0.2. Yeah. Oh, I just dismantled it from a full bridge rectifier, and it has the same amount of excess voltage, about 75 DC volts right here. I just had it hooked up. And I wanted to show you that the AC, you want me to hook it up so we can see those amps? Alrighty. Do you want to see these amps first so that you have some reference point? I gotta turn all this on real quick. Alright, so we'll turn it there. I'm gonna turn it on. The voltage. I am yeah. And how I'm generated apparently is important to some people. I think it is important to some extent how you generate your voltage. I don't necessarily think that any way is the way that you can't do it, because I'm going to do it this way right now with AC voltage. And turn it on. And the lights, but it's not as bright as the DC one by any means. Check this out. Yeah, that diesel generator on a very miniature scale. This one is like a freaking, that's a diesel generator, and this one when it gets going is like a freaking something louder than that. This isn't it though. This isn't it. All right, here we go. And it's more of a fan than a clunk, especially when it gets going. But I mean, the magnets are just chilling there. I mean, basically. So until it gets moving, so all right. So 400 milliamps. Oh, bye, Oval. Thanks for coming by. I really appreciate it. All right. See, this one did, like, will let go. It'll let go completely. But that one's louder than the big one, like a lot louder. All right. So the whole point of all this right now is to show you the light and those amps right there, 0.4 amps. All right, now I'm going to hook up the bridge rectifier. It's those cores and how loose the magnets are. Listen to that. But once you get it going, forces take over and it's pretty stable. Alright, so the coil's hooked up. And then we'll hook up. Alright, that should. Let's make sure we're working with DC. Yeah, we're good. So 9.16. Oh, I didn't hook the light back up. I knew I missed something. Because the light didn't turn on. I didn't even plug it back in. Alright, so get those amps. See, it just takes a little force. This is not right. Because the light's not on. The amps are set. There it goes. See how much brighter that is? And it ate a whole amp just turning on the light. So I mean that's real. That is a real expenditure of energy right there. Alright, here, let me show you again. Except this time I'll show you instead of showing myself. I keep on thinking you can see this, and then I turn around and it's like you can't really see it. Look at those amps, man. That is crazy high. Is it fake? I don't think it's fake. Alright, I would not put this on here if I thought that this wasn't a real reading. That's 2.7. I bet you if I touched this circuit right now, I would shock the crap out of myself. So let's turn on the light. Watch what happens to the amps. You spends a whole amp turning on that light. Now I want to get the voltage. $116 DC volts without the light on. No frequency through the through the rectifier. There's no frequency through there, which makes me think there's not going to be a wave either. There is a wave. Oh, look at that. McDonald's wave. DC rectified. So what it looks like it does is it takes the spike from the bottom and moves it to the top, like right next to the top spike. That's what it looks like it does. So you like turn it upside and you get a little McDonald's thing going on here. Really neat. It's like, looks like 200 volts. 200 volts spikes there. I like it when things work the first time. But you hear that, right? I mean, that is a bandsaw. Maybe not that fast, but it's faster than what I'm used to. All right, now let me see what the wave turns into. Let me just put this like that. I know you can't really see it that well, but you can see it a little bit. We're going to turn the light on. Let's see what happens. Nothing. Look at it disappear completely. That's amazing. I had no idea. What is that all about? That is amazing. And that's because maybe the bridge rectifier is messed up. I'm thinking that it's the bottleneck is in the bridge rectifier. I don't know if they can get messed up though. I don't know what they're made out of really. I know they're a bunch of like diodes, but what material? I mean, does it burn out? Is it capable of burning out? I'm loving this, man. And I got those magnets are coming today. And I got some reed switches that are coming today. This is going to be awesomely cool, like fun to do. I've never like I made one rotor this way. And it was pretty good. It was just off balance, like most of my stuff is. Because I don't use professional quote-unquote software. I use Tinkercad. I think I do pretty damn good for Tinkercad. It's the awesomest, like, for what it is, it's probably the best one out there. But it's not a CAD software, like, with the sketching part. So there's just some stuff that it can't do, but I like it. But that stuff that it can't do would get rid of these little tiny discrepancies in measurement. I mean, they're freaking small. If you look at the rotor, you can't tell that it's got an imbalance in it until you get it going at a certain speed, and then everything starts going shaking because it's not balanced. Admittedly, man, none of this stuff is perfect. But I make do with what I have, and I get better at doing it each day. I do want to learn how to use typical CAD software so that I can draw out what I'm going to do. But you know, I've gotten used to doing this, so it's all right. I'm not complaining about it. I just I know there's different ways of doing it. Designing your stuff. I like Tinkercad, I really do. It's been, in my opinion, really easy to use. Now, what this setup does not need right now is these cores. Now this is 45% iron. That's all coming from the core that's in here. You can see it even shake. But yeah, I mean, why do I say it doesn't need it? This particular setup does not need it. And then the fan kicks in. There's like a fan there. But you know, I'm gonna put these back in because there's a lot of benefits from having one. Like I've been trying to get them all the right size, but these are a little big, and I'm pretty sure you can stick a coil on the end of these. Diesel generator. See, now what happened there is when I put the core in, the amps draw went up to 3.1. Just for me putting that core in there. Yeah, I don't know, I'm kind of in the mood to do something new. Whoa, okay. Hmm. Because when you get that instantaneous amp drawn, you're already at like 2 amps before you get up to where you need to be. Something's not right. And I bet it's because of how that core went in there. I'll have to fix that later. Now we're going to do the 12-volt battery thing without turning the little one on. Alright, 12 volts. God, that feels good. That wind blowing on me. Right. And we got those little M&Ms. Now I can't turn the other one on because that'll be exactly what you all want to see, right? Let's do it. Frick, man, let's do it. All right, here we go. 12 volts, 1 amp. .4 amps, dude. So it kicked on, but I don't think it stayed on. That's on. I think it's working all right. Whew! Man, that hurt. Just a little bit. I mean, it's pointy. Yeah, 10 volts is too high for the system. The little one, anyway. Wait a minute. I got an idea now. We're gonna turn everything down, and then we're gonna just run the little one. The only reason this makes any noise at all right now is because of this coil. That's all I've been trying to say. Alright, so we'll go up to 12. And yeah, I went up to 3.5. I don't think it works very well when it's that high. Yeah. Something's not quite right with this. Let's turn it down a little bit more. Perfect. See, that's what you need right there. .2 amps on its own. I thought the little magnets would have allowed for less of an amp draw, not more. Oh, you can hear that. Holy smoke. Yeah, that is the coil in reaction to those magnets, which is it. Alright, I want to see how much we can generate with this one. It's got less magnets, but they're stronger. But these magnets will saturate the coil like super fast. Well, that's running pretty smooth. I like that. What does this say? Anything? Nothing. $69, 70, 70 volts. $1.5. So there's a little bit more generation going on with the 6 magnets than there are with the 4 bigger magnets. Which I find to be very cool. And it might be because the magnets are smaller and they're saturating everything less. This is a pulse motor. I know everybody wants me to say free energy and everything like that, but I don't believe in that. I really don't. I believe in science. This is all real. I believe in science. Okay, it doesn't necessarily mean I know what's going on or what might be broken in my system, but this is a almost 2 years of gathering information on YouTube from people that do this for a living. And all of it is real. Okay, the fact that I put 5 volts in and 0.3 amps in, and I get all this out on the other side. Let's see what I get. Oh, wrong hole. There we go. 1.2. 0.3 in. Now see, I think that's a little high. But because the light, the load, the coil, and the meter are all on the same, it might be real. Like an actual reading based on the electricity going through this light. It comes out the other side either with more amps or less amps than it went in with. Like a converter or something like that. It's the only thing I can think of. I think that is a little high. But that is the reading. And that's just, I think it's because I'm running this light. But I think it would be even higher if I turn the light off. 5 in, 1.4 out. And that's 5 volts in, 0.2 amps in as this thing gets faster. Okay, and yeah, let's like 64 volts. And that's off of this coil. And I've always known that it's a powerful coil. It's 18,000 turns of 32 gauge with a soft iron core. It's going to generate me some electricity, especially when a magnet passes by it. Like only when a magnet passes by it. It's a single file coil. That's what it's designed to do. That's where it's all coming from. And that's real. It lights this light up. Okay? It's that real. Now, is it necessarily usable like SG is usable? I think some of those amps are fluffy. That's what I said. I think that's legit. I mean, it can't be that high. Unless the light has somehow buffed it up or changed some of the volts to amps. Now that is a possibility because the volts are like 30 to 40 less volts with the light off. Or with the light on, 30 to 40 less volts than with the light off. That's what I'm, exactly. Right, good. And I'm trying to figure this out as I go along too. There are like people that, are, and I'm thrilled by it. I literally am. I'm like, wow, man, what's going on here? And all this is a pulse motor with 2 bifilar coils. There's a 30 gauge here and a 30 gauge here, trigger coils that are swapped. So this trigger triggers this coil drive and this trigger triggers this coil drive. And there's a 20 gauge drive, 666 turns. This drive system right here hasn't failed me once since I got finished putting it together. It started every single time without fail. And I'm like, wow, this is awesome. You might consider that little bit that I just did a fail, but I never started it. I noticed that the amps were high and I just never started it. So, right on. Can't believe that's 5 volts. What stops? Oh. I see what happened. The I only charged it for a couple minutes. So that's what's going on with that. That kind of sucks. All right, so that'll charge up. Whew. It's getting a little hot. I think I'm gonna. Thanks for the heads up on my tester there. I need to charge it up. Now at 9 volts, the 4 magnet rotor should be moving faster than the 6 magnet rotor. But the 6 magnet rotor should be generating more electricity off of this coil at the same speed than this one, this rotor. It's weird, you know, you're trying to find that happy equilibrium and it's like, haha. It's a give and take at that point. It's like, you want more electricity generation or do you want more speed? And there is a threshold where more speed, and it's exactly what that means, more generation. But if you don't ever reach that speed, like something like this, is only going to go 1,000 RPMs before it starts wobbling all over the place. So, yeah, I know. This is the closest one I've got to doing anything like that, and it moves, 300 shy of 2K. That's good for me. That's fast. So that's 1,700 RPMs. Woo! That's an accomplishment for me, actually. I've never made anything that went that fast, or I never had the ability to check anything, and I know that it's never happened before. See, with that amp increase, this one picks up speed too. I can hear it. Woo. It's got the added bonus of having the external trigger, but also having a trigger inside of it that doesn't really belong to it because of the way I have it hooked up. You get the awesome SG effects of having a bifilar coil with the added effect of having an external trigger. So I mean, it's awesome. It's double awesome. Does it go faster than 1,000 RPMs? No, but it's double awesome anyway, man. It's double awesome. You too, Peter. Welcome. You're the man. Does a point have to be free energy, whatever you want to call yourself? W, sir. What up, my man? Woo! Where'd you go? Say what now? Alright, so we're just juicing up that meter right there. Alright, so there must be some new people just in. This is not a free energy presentation. Unlike some people that I work with, I do not believe in free energy. I believe everything has a cost, regardless of what it looks like. There's a cost somewhere. Like we're gonna start here. I'm gonna put 5 volts in. And we're drawing 0.4 amps. And that's what's going into these 2 coils right here. And these 2 coils over here. So this little rotor and this rotor, these 4 coils are now consuming 5 volts and 0.5 amps. Now, this coil, which is not part of that system in any way, shape, or form, save for the kinetic energy and the magnetic energy. Only thing that's linking this coil to these 2 coils is the rotor. That's it. Kinetic energy, 100%. Magnetic energy, 100%. So 200%. Alright, so we have 63 volts of DC electricity coming off of this coil. That's DC, the same as going in, right? This is the amps. 1.3 amps. So 1.3 amps coming off of this coil. And it makes sense, people. It really does. You got 5.5 going in. And you've got virtually 65 and 1.4 amps. So I just caught my finger on something. I hope it was this. That'll be easier to negate. I see some of these are now touching each other, which I know is not good. All right. Now let me see. Now, some of these readings do not go through a bridge rectifier, at least not my bridge rectifier. The current, the frequency, the capacitance of this coil will not breach the bridge rectifier, but when I hook it up AC style, it all works. So I know that the bridge rectifier is some sort of bottleneck for waves. Like my meter won't read through the bridge rectifier. It'll read the amps and the volts. Oh man. I've seen things that I can relate to electromagnetism. That I can relate to electricity and how it behaves or lack thereof. Hmm. All right. Oh, I want to show you guys this. It is like an electromagnet, a U-shaped electromagnet. And I wrapped it bifilar. Okay. And then I took the trigger and I cut it in the middle here. So now one of these is the trigger for the whole thing, and the other one can be wrapped into the drive. I didn't see the point of having a trigger here and a trigger here because they'd be fighting against each other. But the rest of it is all one wrap. It would have been, the same way, but I cut the trigger in half, and it works. It works. I think it's going to work even better now that the reed switches are on their way. But this little thing is wicked. It works. You put it right there, and that little space in between, man, that gets really active. Now, I'm probably going to make another one of these and wrap it with 20 gauge, because this is 26 gauge. So I'm not even sure these two fields are actually close enough to interact with one another. But I know with 20 gauge it won't be a problem. I printed it. You can print that, Peter. It's 45% iron. So I got these two SG circuits, SG generator circuits. It's from K Energy, and I want to hook up one of them to two batteries. Is that doable? Oh, you want that? Well, I'm gonna have to redo it actually. I'll send you the complete file. Yeah. Right on. I feel you, Peter. But you see, the problem with this one is that I ran out of filament. I didn't even really run out, man. It's like the nozzle, the nose, or the hose that hooks to the nozzle popped out of the nozzle head thing, and this last little part. I didn't have any filament to print it, but it didn't stop because the nozzle had popped out. And it just completed the whole thing without actually printing the last part of it. So I couldn't like stop it, or it didn't stop itself. I was gonna have this last little part be copper and have like the end of these bobbins be copper. I think it would have worked out just fine. Yeah. So I got reed switches, and then I've got axial flux rotor with ferrite magnets. I'm going to put the little bricks in here, and then I'm going to make a little donut, seal it up, leaving a hole in the center, put a couple bearings in it, and then the coils go on the top and the bottom, or the sides, instead of out here, and that's awesome. I gotta find a better way to wrap them. And then I think I'm gonna make, yes, Peter, that's the man right there. He's the one who got me interested on the axial flux aluminum motor. I've even given him a few shouts out in a few of my live streams. I've been watching him since he started posting, pretty much. Because that, I mean, even the DC version of what he's got going on is really powerful. And you know what I got on everybody pretty much is I'm not afraid to I'm not afraid to I'm not afraid to mess up. I don't have to say the word to get my point across. You know, I learned from doing stuff. I'm not a second mover. I don't you all can learn from what I do. That's cool. I'm learning from what you teach me. Now you can learn from what I do. You know what I'm saying? And if I give you an idea, if you see something that you like, you know, and it gives you an idea, then build something. Show everybody. I mean, Peter has got some awesome stuff on his channel, man. He's got 2 coils that when they work together, they generate a frequency of like 1.28 million hertz. Listen to that. That sounds like a horse galloping, dude. Oh, that's pretty cool, man. Is that his latest? Oh, dude, man, when I saw him, like, here, I gotta show you these coils that I wrapped up. I'm pretty sure they're all wrong. That's why I haven't put them in play yet. But voila, you know, the bottom are all wrapped counterclockwise and the top ones are wrapped clockwise. I don't know if that makes a difference, but they're supposed to be north, south, north, south, north, south, north, south. Each leg of the coil's got to have a polarity that's, you know, opposite of the other one. So all the ones on the bottom are wrapped counterclockwise. And then these two are wrapped clockwise. And they get plopped on the top like that. I just have no idea how to hook these up, man. I don't know how to. I got a signal generator right here, so I know we can put that in play. I just have no idea, like, because there's so many connections here, how to hook them up. Sweet, man. As long as it's easy, dude, that'll be a load off my shoulders. And then I can get my aluminum rotor in play, or I can even get this new rotor in play. But I really made these coils for the aluminum rotor. Big Red? Yeah, the Barrick, dude. For sure. Um, yeah, this is going to be the rotor for that axial flux. Yeah, that's going to be sweet. Man. Mm. All right, you're talking about like the neosphere kind of thing. We're going to try and spin something. All right, cool, cool. Yeah. Heck yeah, man. The guy, man, Samuel Bluestar, dude, he can do it. And it's just a circuit that I saw for this thing kind of scared me. It was like, whoo! I mean, literally, get it. I mean, I can do it with permanent magnets well enough, so that should work with, yeah, I hear you. I should probably, with this style of motor, practice safety a little bit. And well, yeah, I should probably get a Varick, some sort of transformer, AC power source. Cool. Heck yeah, under 100 bones, that's awesome. Sweet. Only another hour or so and my stuff will arrive. Now, I have an idea about getting these things to spin. Now, since this one doesn't have a maglev, gotta balance it on a flange here. Alright, and then we need the cores back in. So I'm thinking that if anything's going to catch these, it's got to have a core in it, because these magnets are weak. Oh, this should be awesome. I don't know if it's going to like gyro or anything, but we'll find out. It should. Why is it doing that? Yeah, I don't know why it's doing that. The amps are shooting up like transistors popped when I put this core in. Oh man, my daughter just said something disturbing. Uh, I'm gonna have to go on the other side. Let me see if it's gonna happen. Yeah, that's so weird. I don't understand. It might have crimped the wire. Hello. That's not good. This isn't good. And I don't know why it's doing it. Now it'll work just fine. Every time I put the core in, it starts drawing an obscene amount of amps. Just this core though. Oh, now it's alright. I don't get that. Alright, let's see. Can't really tell. I don't think it is working though. See if we're getting any voltage from the magnets I'm assuming or hoping will work. 5, 4. Yeah, I don't know. Can't really move them any closer. Yeah, I don't know. But we got this one right here. It's one of my smoothest ones. It's got awesome bearings. They're stainless steel bearings, but they're still awesome. Now that's a hit right there. But it's it's weak because the magnets are weak. But it'll go really, really fast, I'm pretty sure. 13 volts. 15. Nice. The amps are slowly increasing. Alright, we're going to move it up a little bit. Kind of try and get to 12 volts. 0.9 amps. Look at that thing move. I wish I had a tack, like strip on it, but I don't. Eight 800 RPMs. Wow, four, a lot more. But I think all in all, the best rotor is the 6 magnet one. I'm going to grab that right now. That one is really smooth though. I really like this one. This thing is light as a feather. This one weighs like 4 times that one. I've been meaning to get the toroid off the bottom here to free up some weight and then just ride it on the flange. But I gotta take all the magnets out and then chisel it off and then put all the magnets back in, and I haven't done it yet. So we drop that. Is it too heavy now? It's on a maglev? Probably. That's why I'm gonna take it off the maglev. You can do anything with knowledge. Oh. Oh. These aren't swapped. I must have put them back to do a demonstration, but I'm going to swap them. Let's see what we can get. Alright. Come on, give me some love here. Alright. Now let's see if we get a boost or not. Or what's going on now. It does sound pretty loud, doesn't it? But the amp draw is only 0.5. Now it's 0.9. Okay, that's more like it. Okay, so that's not stable. I'm pretty sure it's just something's touching something. It shouldn't be. What is it at 5.5 amps? 600 at 0.5 amps. Oh man. Woo! 841. $8.45. It is pretty heavy though. You're right. Not gonna deny that. But what I have such a problem with, just, I put a load on the circuit. I put a light. I attached a light, a 100-watt LED to this and the multimeter, and it's still coming out at like 75 volts and up to 2.3 or 4 amps, up to 2 amps out. I feel a little weird about the 2 amp thing. I don't know about that, but I mean, it seems like a lot, but I don't know. It seems like it could be right, actually. So there's 124 coming out in DC voltage right now. Now we'll turn the light on. You get a load on the rotor, and it drops to 76 volts. That'll level out. The rotor will level out. Now let's do the amps. See, 1.6 amps with the light on, 2.4 with the light off, 2.5. And then it'll continue to increase as the rotor speed increases. See, the problem with this is that the load does cause a load on the rotor doing it this way. So you can't, it's very limited as to how useful it is. Now, I didn't say it was useful. I said the meter said that there's 2.853 amps coming out of this coil, and I believe it. Because when I turn the light on, and amps are obviously being drawn from the light, it draws a whole amp from the store, how much is there, and the light turns on. And 30 voltage, 30 volts. So more like 50 volts when you know, incorporate all the slowdown and stuff like that. Is that really you, Ben? Holy cow. There it is, man. Iron Man in a nutshell. I do it all with my heart. I mean, I truly, deep down, I love magnetism. Not just electromagnetism, but all types of magnetism. All types of bipolar communication and languages. So, you know, binary language is, I like binary language, zeros and ones, I love it. And if we just use the bit rate the way we normally do to decipher the code, then, you know, it's 8. You know, there's lots of things from, I forget whether you start at 0 or 1, but it gets up to 8 and then 16 and 32. But it goes up to like 256, and then it kind of rolls around. Now, I'm sure that there's more advanced binary language that I haven't got my hands on yet, but all you need is a legend and the rubric to show you how it works. And then you can take the code of any number or letter. Alright, you can take the code of any number or letter, plug it into the rubric, and it'll give you, you know, your 8 ones and zeros. It's pretty cool, and it's easy. You know, they gave me a legend for ASC11 or ASC2 or something like that. I did it all in a night, and I printed out like pamphlets for my classmates on how to do it. It's like, I don't know, man. I was really hyped up about the whole thing. So we did like 1 through all the letters of the alphabet, a few, you know, punctuation, and 1 through 99. And I did it all in a night, and it was cool because I had all these ones and zero combinations like stacked up on top of each other all the way, like 160 of them. And you can write, you know, you can write letters and notes and stuff like that in this code. All you got to do is know how to break it down. See, and that knowing whether 0 or 1 is where you start is real important, and I've forgotten that. But this is kind of like, if you can see it a little bit, what it looks like. And that's 369. That is the code for 369. So that would be a pattern of on and off for a pulse motor. That would be, anything that's binary, anything that's a language that requires, an on and an off. That's just electricity. That's how we do it. North, south. But that isn't necessarily on off, but it is binary. So I mean, magnetism falls in that genre. And really, it's see, but what having the 1 or the 0 be where you start or end, or be where the equation is, knowing that is 100% going to make or break whether you get the right answer. Everything else is just like so like say your key answer is 99, okay? So does 99 go into 256? 0. Does 99 go into 128? 0. Does 99 go into 64? 1. And then you gotta do the subtraction and find out what's left. Or, man, I forget. You could just take the same number across, but I think you just gotta subtract and work with what's ever left of that number for the next one, which is gonna be 32. So 99 minus 64 is going to be 35. And then 1, so it's going to be 0, 0, 0, 1, 1, and so on and so forth. Alright, so let me check the time. Oh, man, we are just moseying right along. 5 o'clock should be when my ferrite magnets get here. And I really want to hook up this U-shaped coil to a reed switch. I think that'll be awesome. All right. So I guess you hook all the coils up in series? I don't know. We'll have to get that spinning. And it seems like the next logical step to with the axial flux to get the rotors spinning. One, the aluminum rotor. And this is kind of heavy, but it is a solid piece of 1/4 inch or 3/8 of an inch of solid aluminum. This is really, really light. This rotor is 10% at trihexagon, so I mean it is light. And then the ferrite magnets will go in here, or that's what's supposed to happen. The only reason that isn't going to happen is if the dimensions are slightly different than what they said on the site. In which case, I probably should have waited till they got here before I did the rotor. But I got enough blue to make another one, so that should be pretty cool. Oh man. Yeah. Okay. So I'm thinking that when I get the axial flux coils set up, I'm going to need to run both channels on my generator here. One for that's going to do the south and one that's going to do the north. And the north, I believe, is on the bottom and the south is on the top. And it should make a pretty awesome, like, I don't know exactly how it works, but that's how I think it works. It should make a nice little pulse there of north and south. Oh man, I hope everything's good. You know what I wouldn't do for a VCR rotor, right? I wouldn't do it myself, but I might pay somebody to get me one. It's not like I have anything against it. It's just that the last time I tried to take anything apart, ended up with a sledgehammer, and the guy who gave it to me to take it apart was just blown away. He was like, "No, you didn't! No, you didn't!" And I was like 10, and I was like, "Yes, I did. Here you go." And he was like, "Nah, no way." Pulse motor mayhem. Mm. Now the one thing I really can't wait for is that 20 gauge that's coming. And then I have 32 gauge to roll as a trigger with that. Don't have any 30. I wish I had some 30. Tony Stark put this together in a cave with a bunch of scraps. Yeah. Mr. Stain was upset. So I don't know. I know I got a few more things that I want to do before, I die. And one of them is build at least complete some semblance of the rotor. It's just that I need to be able to cut and wrap around the aluminum on this rotor. And that's going to be hard. I mean, I got to cut that. I should be able to, at least from an edge, cut it the right way. So, oh yeah, let's turn that off. And if I can get this, see, the axial flux is just the start of like a whole new can of worms here, because the aluminum is going to go every other like cul-de-sac here, part of the wheel. If we can get this one to spin, we can definitely get this one to spin. Virus Pizza, I do not know what the Fent reactor is. And if you could find a way to translate that so that I can understand, that would be awesome. Let me show you what's going on in the other, you know, every other. Let me show you these. So like every other hole here, there's going to be one of these like, neutrons, and they're supposed to spin. I'm not sure exactly whether I'm going to keep them like this and try to spin them in a like a, you know, like a very light bearing just resting in there, because they're supposed to rest so that the square, so when you look at it, you see the square. So when the magnet goes past it, it hits the flat side and makes it spin. Because if it hits the edge, then you get the least amount of area on the neutron affected by the magnet. You got to have it on the edge up here, and that way it'll spin the most. And that's why it's got to be on a 45-degree angle. And that's why you got to use that really specific thing. I think it's called like a Turon or something that goes with the neutron to hold it at a 45-degree angle, just in place like that. Oh man, I think I'm running out of batteries, folks. Yep, we're gonna have to call it for right now. But I'll definitely get back to you. Thank you very much. I'm making the motor to pass time. I'm making the motor because I can. I don't really have a end game. It does generate electricity. I didn't make it for that purpose though, but it does. This coil right here generates enough for the light, and to have an amp and a half beyond that with about 75 volts. But that's more like a transformer, a kinetic transformer. It takes the input and it runs it through a bunch more copper than is in the drive. So that copper ratio you factor in, and everything will balance out. Thank you. Thank you very much, people. I really appreciate you coming in. I'll catch you later. I'm probably going to be on later tonight. I just gotta. Thank you. Thank you. I really appreciate it. I'll be working on a goal. People keep asking me what the purpose is. I might as well put some effort into coming up with what that might be. Oh, I still got 20%. I still got 20% on the battery. I think we can keep going. Thank you very much. Yeah, I'm revigorated about the neutrons. So I need to print 2 more of these. Now the cool thing about this is there's a hollow sphere in the center. There's a hollow sphere in the middle of these. And they're copper, and the air trapped inside the sphere can ionize, which will, when spinning, increase the speed. Yeah, this is supposed to be a time machine, actually. I mean, it's downscaled tremendously. It's supposed to fit a person inside of it. And I'm just trying to build a little one that will represent. And I slowly am coming up with the pieces and putting things together. And I mean, here, let me show you what I have for a first. A first iteration of a coil that would work on this thing, and it go in like this. Okay, so you kind of get what goes on. And then the Utron would be at a 45, and it would pass. It would make the Utron spin, and then, you know, it would. And it's supposed to be gyroscopic. So I'm thinking, it was mentioned that I should probably use thinner wire to wrap around the coil as a primary, or is it secondary? I don't know. I'll have to confer with my co-counsel on that. But yeah, it's supposed to use pretty potent. You know, that's why I think there's got to be a, like, at least a bifilar going on. Right here I got a 14 and an 18 gauge coil. It's probably about 35 turns, maybe. And it should have a banging current, especially if I like wrap them in series or something. And when it hits the aluminum, it should push the rotor, and when it passes by the Utrons, the magnetism should spin the Utron, and having every other push it should keep it going. And that'll perpetuate a cycle, which will increase every frequency. I don't know exactly what I'm trying to say, but every time it goes around, it'll be faster. And the Utrons will be faster. And everything will keep going faster. And the cool thing about this is the rotor's spinning one way, the Utrons are spinning the other way inside the rotor. So that, you know, that in and of itself is going to be freaking awesome. It's going to like tear the time and space fabric apart. But you know what? I'm pretty sure that tearing the time space fabric apart happens on a daily basis. Happens all the time. Just people don't do it. I'm pretty sure all this stuff is natural and it happens all the time, and it just you know, even down to like the atomic bomb or like a neutron bomb or something like that. The supernova would represent, or the other way around, or something like that. The phenomenon is natural. It occurs naturally. And the reason that I figured this out was the gyroscope. The gyro pulse motor that I built, I didn't have to do anything to make it gyro. That does it. It does it naturally. It just happens. You just turn it on, and if you've hooked it up to the point where it's going to spin, one's going to spin one way and the other's going to spin the other way. And it happens every time. It does. It's not something that you made happen. It just happens. And it's awesome. I think it's awesome, and just those natural occurrences that made me think that maybe that's not the only natural occurrence. Because I know that I didn't do anything to make that happen. I just put it together, turned it on, made sure that the power was getting to it and that both things could spin freely, and voila, that's what happened. It was pretty neat. Yeah, man. I'm thinking this will only take a second. And that DC motor that I bought, the lathe motor, is freaking amazingly fast. Gotta find a way to utilize it. If I can run it with SG, man, that'll be abundance of quote unquote free energy. But I can't say, I haven't tried it yet, whether here nor there, on whether or not SG is going to be good enough to run it. I don't know. Don't know yet. All right, so we're going to take a look at that. All right, so let's see here. See, all I did was turn it on, and it is gyro affecting. Oh, I think we got a loose nugget here. Wow, it started to, it was spinning itself so fast that it fell apart. I'm thinking about maybe putting the 18 gauge back on there. I swapped it out for some 24 gauge. So I thought like it would be. Thanks, Mike. All right, but as of like the most that I've been like, you know, when I put them together, they're power hogs. They require a lot of voltage. Yeah, anyway, I think that's really cool. Oh. All right, so it's three. You got three large neodymium magnets in here. Large round ones, the square ones, it doesn't matter, but the big 40 millimeter ones. Then you got a reed switch, and you got three bifilar coils that are wound in series. Coils like that, you're best using a reed switch, I'm pretty sure. Like if you like cut out one of the bifilar coils, then you could probably use a transistor. But I'm thinking there's way too much wire there. But I mean the magnets are strong, so they could probably trigger. I don't know though. I mean I've had to go, both ways kind of. Yeah, I gotta work on a better brush, is what I'm talking about. Because this essentially is a brush DC pulse motor. Essentially what it is, there's two brushes on this that make it do what it does. So I'm thinking that if I swap out that 24 gauge with this one, and then I had it pressed down with some like that on the plate, that when it spun around, it would stay on the plate. Because this duty cycle is only like 60% because of it's not touching the plate the whole time. And you can tell how much slower it's going than the first one. Then the first time I turned it on, and then the brush went flying, and when I put it back, it wasn't the right way, I guess. I'm not that sad, Peter. I don't know, man, because there's just certain words in the English language that I shy away from. I mean, it may equivocate to me believing in it, but, I know the science, so I know that there's a reason why it is the way it is, and exploring that reason is what I'm really interested in doing. What I believe in is bridging gaps, man. There's got to be a way to bridge this gap between the scientists and the people that believe that it needs to start progressing and that it can progress. That's what needs to manifest, and it doesn't just need to manifest for me, it needs to manifest for, you know, all this to be able to continue. Because instead of like telling me that I'm a liar, you could say, it, you know, I think you're doing it wrong, you could try doing it this way, and then tell me what happens. You know, you could try that instead of just saying, because lying is like falsifying information with intent, okay? And you have to have intent to lie. And yes, you do. Okay, basic ignorance is not lying. It's not lying. And I just, you know, and that there's like people from all different sides of this thing coming at me, good and bad, and I am thinking that there needs to be some kind of, you know, at least among the adults, you know, some sort of chat. There should be some sort of powwow going on here where, you know, the scientists break it down and they say, yeah, I saw this happening, but this is why that's happening, and then explain it so that, you know, everybody understands it. You got to go on the premise that there is no free energy. It's like it's not free. No matter what you do, you still got to pay somehow. And I've seen, it doesn't matter. It doesn't matter. As soon as you move that first molecule, you have applied all you need, basically, to make a chain reaction that will, you know, cause what you want to have happen. All you need to do is move one molecule. So it's not like you can see, it's not like you can say that it exists, because, I mean, you breathe and you've moved a molecule. Oh, so yeah, there was, like, I'm not saying anybody currently, I'm just saying there have been some people come up to me calling me a liar because I didn't put a resistor across my load, and that my readings were all wrong. I'm not trying to rewrite thermodynamics. I'm not trying to say, but what I am saying is that I've seen something. And if you can't explain to me, other than a broken or a fixed multimeter, why it happened, then you don't have a say, really. Okay, Isaac Newton would say, wow, I saw it too. What was that? Or he'd explain what it was. You know what I'm saying? Have you? I can barely read, man. That'd be awesome, man. I'd like to see that. That'd be cool. I wish. You know, maybe with AI the way it is today, that I could, you know, talk out a book and they would write it down. Yeah, but I'm not going to be the one to say they were talking shit. Thank you for backing me up, though. I do appreciate that. Yeah, I talk with the people that want to talk with me as often as I can. I've talked with my brother quite often. He says you need to be less mean. And I agree with him. I need to learn how to let stuff go like a lot faster than I do. I think I do a good job, but it's like you gotta blow it off sometimes. Be like, oh man, and maybe talk about it with your peers later on. Be like, hey, I can't believe what happened. You know. That's awesome, Peter. You do know that you're part of that driving force, though. You do realize that it's only going places because there's people there that think it's going places. I'm one of those people, but you know you're one of those people too. I'd love to chat through some stuff with like people who know about it, but I mean I have a strong sensation that a lot of them have dismissed me as being less than professional or being a mean person. And yeah, man, I've said and done some things that I may have even quasi regret doing. Mm. Ah, sloppy version of Rick Moranis. That's awesome. No, 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 no. You're right, man. I totally need to think about what's going on the table here differently. At least on the table. Abel. Yeah, I've no doubt, man. No doubt. I've actually had an accident or two happen. Not here. It happened about a year ago. But I haven't had even smoke rise from anything. Been keeping the heat relatively in check using the SG circuit. That's true. I mean, I haven't like studied physics ever, and I wouldn't take it as gospel like I wouldn't take the gospel as gospel. I don't believe in that. I believe that's a book. It's like a lot of other things are just things that people wrote down or things that a congregation of people wrote down. You know what I mean? Like you get a group think thing going on and you can write anything down and you have 100 people backing it up and it's like whoosh, it could spread like wildfire. And like there was this show and all it took really was one guy to chant this guy's name and it just all kind of flipped on this guy and that's all it took was one guy chanting his name. So, you know, I don't know where that came from, but I know the show, and it's a pretty good show. Hello, how you doing, son? All right. gotta speed it up a little bit, so we'll stop catching that thing. So 7 volts is good. So there's your typical 12 volt battery with your trigger coils swapped. So if you get what I'm trying to say by that is that this trigger coil is triggering this coil and this trigger coil is triggering this one. So you get the effect of having it be outside, but then having 2 of them, you get the effect of having the light up through the SG, but it's not hooked up through SG right now. It's hooked up to this coil. What are you trying to do? What are you trying to do, man?
Mm-hmm.
You want me to hang it up?
Hang one up.
Huh?
Hang one up.
You want the TV?
Oh.
Huh?
I want the TV.
Oh, you do?
No.
Okay, well, can you stop playing with the camera? Alright, hey. Okay. That's cool. I love him, he's awesome. It's Caleb, my son. So I think the last thing I'm going to do tonight, before I go to bed maybe even, is take all this apart. Keep the circuits together, but I'm going to take all this apart and I'm going to hang up all my my plugs, my clips. I'm going to get all this stuff where it needs to go. I'm going to put everything away. Oh man, I have to. I have to do that. I can barely. I want to just take it all and throw it to the curb. Be like, all right, we're gonna start over. But I'm gonna do something better than that. We are gonna kind of start over. Um, might have to get a couple different pieces of lumber. But I got some ideas kind of brewing in my head about making some pretty spectacular motors. And like having an end game. I think this can be an end, beginning and an end right here. I mean, this coil could come separately. And I mean, the 180 pulse motor is as simple as can be. And this is it running on 12 volts. So, I mean, you get a battery. Well, you need a battery. I'm not saying I'm going to give you a battery. I mean, here. The shipping on this freaking thing alone would probably bankrupt me. So that isn't gonna happen. But I got two of these SLAs. I broke down and I'm like, all right, what the hell is the big deal about the SLAs? So it's just a 12 volt 9 amp hour SLA battery, and I got two of them, and then I got two power supplies. So technically, I could run this coil and this coil on batteries alone, and they each get their own input. So, and yeah, they'll have their own circuit, but they'll have their own input. It won't be coming from the same place anymore. And I think that skewed a few of my experiments, is having all the power come from the same place. So now every place will have its own power. I think that'll improve how it works. I know I might be just being overly cautious. We're gonna turn it up. Now I'm turning it off.